Alright, so today we're going to be talking about how to simplify, multiply, and divide rational expressions. So we're going away from the graphing stuff and just talking about how do we work with these to kind of simplify them. We've actually already did this. We did this kind of process while we were trying to graph. Remember for phase 2 you have to factor and then cross stuff out? That's what we're doing today. Just on a little bit more of a complicated scale, but it's the same idea. You're still going to factor everything that you can and cross out what they have in common, and that's all that we're really doing today. Okay? So a rational expression is a division of two polynomials. You need to remember that whenever you guys see rational, that's another word for fraction. So we actually have a division going on. That's what lets us cancel. If we have something in common top bottom, that's why we're allowed to cancel things, because it's a division. A rational expression can be thought of as a fraction, right? No duh, it looks like a fraction, right? What's another word for a fraction? Do you guys remember? It's a much shorter word. Starts with an R. Ratio. Right, so we can consider rational expressions as fractions or ratios. So a rational expression is in the simplest form when its numerator and denominator have no common factors. So that's why we're going to do this stuff where we're going to factor it and then cancel stuff out. Right, so it will be in simplest form once you factor everything and then cancel the things that they have in common. That's what we're going to be doing as this first section right here, simplifying rational expressions. So the process here, pretty straightforward. You're going to factor the numerator and denominator and cancel anything that they have in common. And then we're going to state restrictions. This is something that we've been kind of thinking about already, but we haven't called it its specific name. Restrictions are values in the denominator that are not allowed because they would make the denominator be equal to 0. And you can't divide by 0, right? So when we're finding restrictions, we're going to be finding the values that you cannot plug into the denominator, because if you did that, there would be 0. And they're really easy to find. I'll explain once we get into these examples here. Alright, so here's our first one. Right? If I asked you to graph this like we did with the previous lesson, you'd find the horizontal asymptote, and then what would you do for phase 2? You try to factor and cancel stuff. So let's take a look at this. Can I factor x plus 1? No, so the numerator can't be simplified at all. That's just what it is its own form. Can I factor x squared minus 1? Yes, because 1 is a perfect square, so we're going to use the difference of perfect squares. You have to remember that 1 is a perfect square to know how to do this. Alright, once I factor, what do you guys notice? What cancels? Okay, those cancel, so what's left? That's your answer. That's the simplified form. So when they say simplify a rational function, this is what they want you to do. They want you to take the original, factor top and bottom, and then cancel out what you have in common. Alright, now when they ask for restrictions, those are the values that are not allowed in the denominator, and those come from the original form, not the simplified. So when they ask for restrictions, you guys have to look back here before you canceled anything, and you have to figure out what values are not allowed in the denominator. The way you do this, and you can write a little note up here, you're going to set everything in the denominator equal to 0. So basically we're going to be finding the vertical asymptotes. Right, restrictions are vertical asymptotes, essentially. So when they ask you for restrictions, they're talking about what are the vertical asymptotes, what are those numbers you have to jump over in the domain. Okay? And then remember, this comes from the original, so you can write next to it before you simplify. It's hard for me because it's not working English, but you should write before you simplify. That's what I mean by the original form. Okay? So if I look over here, before I canceled anything, I had two things in the denominator. If I set them both equal to 0, what are the x values I would get? So 1 and negative 1, those two are not allowed. Those are restrictions. Those two numbers would not be allowed in the domain. If we were writing the domain like you guys just did on the quiz in that previous lesson, we'd have to jump over negative 1 and 1. That's what they're essentially asking for when they ask for restrictions. Okay? Alright, what about this one? Can I factor the numerator? How would I factor the numerator? There's a GCF, right? What is the GCF? It's negative x squared. Remember, anytime you have a negative in the front, that is part of the GCF, and they both have an x squared in common. So if I factor that out, I get x, careful, what do I have left over? Minus 3. Remember, when you have the negative as a GCF, you're factoring out a negative, so all the signs change. And then in the denominator, I just have 2x squared. Can't be factored, it just stays there. So now that I've pulled out the GCF on the top, what do you guys notice? Is there anything in common top bottom? X squared. So I can cancel out an x squared from both the top and the bottom, leaving me with negative x minus 3 over 2. You can cancel out monomials, binomials, leading coefficients, anything that they have in common, you would cancel them out. Alright, so let's talk about the restrictions. Remember, this is the vertical asymptote. So before I canceled, I did have 2x squared in my denominator. So what value would not be allowed? What would the vertical asymptote be? If I set that equal to 0. Two x squared equals 0. What would x be? 0. Anytime you have a monomial set equal to 0, you'll always get 0 back. Okay, so again, go back to before you canceled anything and set the denominator equal to 0, that would be your restriction. Again, you're looking for vertical asymptotes there. For example 3, these are both monomials, so they can't be factored, but you can still cancel stuff. Do you guys see anything that you can cancel, top, bottom? What could I cancel? The 5 and the 15, right? So what would be left in the top in terms of numbers? A 1, and then what would be in the bottom? A 3, right? So we took care of the numbers. Is there anything I could cancel out in common with the x's? What could I cancel out? An x, right? See how the bottom has an x and the top has an x cubed? So if I cancel out an x from both of them, because that's the most I can cancel out, I have x squared left over in the top, no more x's in the bottom. And then I can do the same thing for a y. So I have 1 y up here and 3 y's down here. How many y's could I take away from both of them? 1. Just 1. So I have no more y's in the top, but I have y squared in the bottom. So that would be your simplified form. So you don't always have to factor to simplify. Sometimes they're both monomials automatically, and you would just chop out whatever they have in common. Okay? Restrictions on the domain. Now this is going to be interesting because I have 2 different variables in the denominator. So we're going to have to write 2 different situations here. There's going to be an x that's not allowed and a y that's not allowed because they're both in the denominator. So if I go back to before I canceled anything, I have an x and a y cubed. So I'm going to have to say x equals 0 and y cubed equals 0. Anything that has a variable, you have to set it equal to 0. So what value of x would not be allowed? 0. What value of y would not be allowed? 0. If you guys want to write a little note, you should notice this happening as we go on. Anytime you have a monomial in the denominator, it's a 0. Right, so you want to make a little note for yourself. Anytime that your denominator is a monomial, the value that's not allowed is a 0. Every time. Alright, what about this one? I know it's a little bit weird because we don't have x's, but how would I factor this? Look at the top first, right? You should never look at it as a whole unless it's just monomials. If you have 2 different types of polynomials in the top and bottom, you need to separate them. So just look at the top. Is there anything I could do to factor that? GCF of what? 3C. So now I would have 2C plus 3 left over. And then because the denominator is a monomial, I can't really do anything to factor it. But I can cancel them out. So then what am I left with? You don't have to write the over 1 if you don't want to. Right? But you'll just be left with QC plus 3. Right? Now go back to before you canceled. I did have a denominator, 3C. That's a monomial. So what number would not be allowed? A 0. Alright? What about this next one? We have 2 trinomials. We're going to factor. Since they're both trinomials, we have to use the x trick for both the top and the bottom. So I'm going to draw 2 kind of smaller ones here and here. So for the top, what would go in the top part of the x? 16. What would go in the bottom part? 8. So what 2 numbers multiply to get 16 but add to get 8? 4 and 4. Can I use that shortcut we were talking about? Why? The leading coefficient is a positive 1, so I get to go straight to x plus 4, x plus 4. Okay. In the denominator, what should be the top part of the x? Negative 24. Make sure you keep the signs. And then in the bottom is negative 2. So what two numbers multiply to get negative 24, but add to get negative 2? Negative 6, positive 4. Can I use the shortcut for this one? Why? The leading coefficient is a positive 1, so I can go straight to x minus 4, x plus 4. Alright, now that I've factored both the top and the bottom, what do you guys notice? You can they have an x plus 4 in the top and the bottom. Can I cancel out both of these x plus 4s and that one? No, it's a one-to-one relationship, so you can only cancel out one of each. So you're left with x plus 4 over x minus 6. Like that. Okay. Now restrictions on the domain. Remember that comes from before you canceled anything. So before we canceled anything, I had two factors in my denominator. I need to set them both equal to 0 to find the vertical asymptotes, which would be my restriction. So what two x values are not allowed? It would be positive 6 from that one and negative 4 from that one. Remember, restrictions, same thing as vertical asymptotes. The two values that are not allowed in your denominator. So that's a 4. Alright, I want to see if you guys can give the next one a shot. Try to try the next one. Factor what you can, and then cancel what they have in common top up. Yeah, so it would be 7 minus x, so when you solve it, you can change this to 7. So when you really calculate it all, you can change it here, so it would be negative x plus 49, and then you divide that by 2. If I look before or after, and then change the 3. But yeah, so when you Alright, what do I do for number 6? How do I factor the top part? Close? Look how I've written it. How should I write the factors? Yes. 7 minus x, 7 plus x. It's very important you guys pay attention to the order. How it's written. If you had written the x first, that would actually be incorrect, because if you swap the two, then it would become negative x squared plus 49, and you have to divide the negative away. So if you swap the order, there's actually a negative at the front with the GCF. So you have to be really careful if you're going to swap the order, you need to remember the negative GCF, or just leave it like this. Right? Now, it's going to seem a little bit weird because the bottom does have a different order, but do you guys see any things that they have in common? Yeah. The commutative property. Isn't 7 plus x the same thing as x plus 7 with the commutative property? So you can actually cancel those out, and you're left with 7 minus x. At this point, you guys can swap the order if you want to. That would really be negative x plus 7. I don't care if you swap it or leave it the same. I don't really mind. So both of those are the same, whichever way you want to write it. But when you guys are finding the restriction, where does it come from? Does it come from this and we say there is no restriction because there's no denominator? No, it comes from before you canceled anything. So I have to set that equal to 0 and find the x value that's not allowed. So it's -7. -7. -7 would not be allowed. Alright, so that's all that you guys have to do for simplifying. You have to factor as much as you can, cancel out what they have in common, and then find restrictions based on the denominators. Okay? The other things we're going to talk about are multiplying and dividing, which are essentially the same thing. We just have an extra operation we have to take care of. So for multiplication, it's going to be the same thing with one extra step. Alright? You're going to simplify by factoring. Alright, we have two separate rational functions. We're going to factor and cancel out anything that they have in common top bottom, and then you're going to multiply any pieces that are left over. Alright? So simplify and factor each of them separately. Cross out any common factors that you see, which can come from across the multiplication sign. So if you see something in this numerator that's in common with the denominator of the other fraction, you can still cancel them out. As long as one's in the top, one's in the bottom, it doesn't matter which fraction it comes from, you can still cross them out. And then you're going to multiply anything that's left over, and that's it. Okay? So it's like two simplification questions in one, and then you multiply whatever's left over. Alright, so for this one I have two rational functions that have nothing but monomials. Do you guys see anything that can cancel? And it doesn't have to be just within one fraction. You guys can cancel diagonally. The 4x squared and the 12x to the 4. What would be left over if I cancel those? The 4 goes into the 12. No. The 4 goes evenly into the 12, right? So there's only a 1 left here. And then a 3 here. And then what about the x squared? Is there anything left over from this x squared? No. But then what's left over the x to the 4? Alright, so we really only have a 1 left over in the top here, because the 4x squared completely canceled away, so we only have a 1 left over. Is there anything else that I could cancel? The y's? Do you see a y in the top and a y in the bottom? Okay, so I can cancel those out, and it's going to be a little bit sloppy because I can't write very accurately. Alright, so what's the only thing that's left? No, it looks like x's. I know, I'm sorry. I'll just scribble them. There we go. So what's left over in the numerator? A 1 and a 7. So what happens when you multiply those together? 7. Then in the denominator I have a 5 and then a 3x squared. Multiply them together. 15x squared. That's multiplication. You chop, 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 so you can't chop anything else, and then you multiply them together. Alright, restrictions. Remember there are two different variables, so two different types of restrictions. They're monomials, so what's the only value of x that's not allowed? 0. And what's the only value of y that's not allowed? 0. Again, rule of thumb. If they're monomials, the restriction is automatically 0. Alright. This one is not monomials. This time we have binomials. So how would I factor these binomials? Let's take it one step at a time. Let's look just up here. How could I factor 8y minus 4? GCF? What's the GCF for that? 4. So I would have 4 on the outside and then 2y minus 1. Okay, let's go to the bottom. How can I factor this? GCF again, what's the GCF? 5. So if I pull out a 5, I get 2y minus 1 again. Don't cross out until the end. Be a little bit patient. Alright, go to the next fraction. How can I factor the numerator of that? GCF again, right? What would the GCF be? 5. So I have 5, and then I would have y minus 3. What about the bottom? 3 is the GCF. And y minus 3. Now that I've factored everything, let's start chopping. What do we have in common? Okay, those go away. Those go away. More. And the 5 and 5. So everything chops. What's the only thing left over? 4 in the numerator, 3 in the denominator. So all of that probably simplifies to 4 over 3. Okay. Now, I have some restrictions. Alright, they're all y's. So look at your denominators before we canceled, I have to set this equal to 0 and that equal to 0. So if I set this equal to 0, what's the value that's not allowed? 1/2. And I have to set that equal to 0. So the two restrictions, the numbers that are not allowed, would be 1/2 and 3. Remember, that's how you find vertical asymptotes. It's the same thing we're doing for restrictions. So are you okay with the first two? Factor everything as much as you can, and then chop, chop, chop. So you have nothing left over. Except for what's left over. Oh, go away and do some page. Okay, fine, I'll do it over here. Alright. What about this one? How can I factor that first fraction? X plus 2, x minus 2. That's how we factor the difference of perfect squares. What about the denominator? X plus 1, x minus 1. Okay. Can I factor just plain old x plus 1? No, so that's just going to stay. What about the denominator? There's a GCF for this one. Guess what do they have in common? X. So if I pull out an x, what do I have left over? Alright, remember this is why I said factoring is an essential skill. There we go. You guys need to be able to factor like that, right? Because we use it a lot in this unit. So you guys need to be able to recognize and factor relatively quickly, or it's going to become rather tedious. Alright, now that we've factored everything, what do you guys see? One in top, one in bottom. Doesn't matter that they're in different fractions. And then the x plus 2, x plus 2. Is there anything else that I can cancel? No? Alright, so what's the only thing that's left over in the numerator? X minus 2. And then what's left over in the denominator? So I have the x minus 1, x. You do not have to multiply them back together. You do not, just leave them separated. So if you have multiple things left over in either the top or the bottom, just write them next to each other. You don't have to distribute, FOIL, anything like that. Just leave them alone. Okay? Now, we have to go back to before we canceled. I have 1, 2, 3, 4 different things in my denominator, so I'm going to have 4 restrictions, 1 for each x. What restriction does this give me? Okay? This one gives me 1. The monomial gives me 0, and that gives me -2. So we have 1 restriction for every variable that you see. Okay? All right. This is the last one, the beast. All right, we have several trinomials over here. So hopefully you guys have a little bit of space underneath to do some x tricks for this. Right at the top of the first fraction, I need 2 numbers that multiply to get 6, but add to get -5. For this first one, multiply. Yep. Can I use the shortcut? For this one? Why?
The leading coefficient is 1.
The leading coefficient is a positive 1, so I can go straight to x minus 2, x minus 3. Alright, the denominator, how do I factor that? X plus 2, x minus 2. So that's a 2. Alright, what about the trinomial? The next one. Multiplies to get what? 2. Adds to get 3. 2 and 1. Can I use a shortcut? 1. The leading coefficient is a positive 1. So I go straight to x plus 2, x plus 1. And then our last one here. Last hurrah. Multiplies to get -3, but adds to get -2. Be careful with the signs, but multiplies to get -3. Say again? -3, positive 1. Be very, very careful, especially when you guys have smaller numbers where they're both negative. You need to make sure you're really careful with the signs that you're using. Can I use a shortcut?
Yeah.
Okay. So I'm going to have x minus 3, x plus 1. All right, once you've factored everything, let's see if we can chop. Do I have any x minus 2s?
Yeah.
One top, one bottom. All right. What else?
X plus 2,
Okay.
and X minus 3.
All right. So what do you think the answer is?
0, 1.
Oh, I heard 0 and 1.
None.
No solution.
It's not no solution. It's not no solution.
1.
What happens when everything cancels?
1.
Answers of 1. I know that's super frustrating, right? We did all that work to get a 1 in the answer.
Kidding me?
I wish I was kidding, but no, I'm not. So if everything cancels, it's not a 0, and it's not no solution, it's a 1. Okay? Now, how many restrictions am I going to have? 4. 1 for each thing in the denominators that you guys have. So negative 2, 3, and negative 1. So remember, anything that you had in the denominator before you cancel, if you set them equal to 0, that's how you get your restrictions. Alright, last one here. This is going to seem more complicated, but it's actually not. It just looks more complicated, but it's not. Okay?
That's what they said.
That's what they do.
What the heck?
Alright, so this is dividing this time. We call these complex fractions because you have fractions within fractions. They're like fraction inception, right? So they could actually write division in 2 different ways. They could write it like this, you can put a little 1, or they can write it like this, a little 2. Right? If they write it like number 1, they're going to have one big fraction bar, and then you're going to have a fraction in the numerator and a fraction in the denominator. Again, that's why we call them complex, because they're more complicated. Or they could write them like this. They're next to each other, and they use a little division symbol. If they write them like this, you guys need to be very careful that you can tell the difference between division and multiplication. Multiplication is a little dot, or an X. Division is that division symbol. Because they're small, you guys need to make sure you're looking out for them so you can tell the difference. Essentially what we're going to be doing for division is we're going to turn it into a multiplication question. Because division is way too complicated to look at and try to figure out on its own. So we're going to convert it into a multiplication question using this little rule, KCF. KCF. My kids last year like to call it KFC, but I was like, don't do that because you're mixing up the letters. KCF. So this stands for keep, change, flip.
Oh,
Do you guys remember that when you were learning how to work with fractions before? Keep, change, flip. You're going to keep... Huh?
That's the same as keep change.
No. Well, sort of. You're going to keep the first fraction of whatever it looks like without changing it. You're going to change the division to a multiplication symbol, and then you're going to flip the second fraction. So this division question right here would actually turn into this. You keep the first fraction the same, change this to a multiplication, and then have the reciprocal of the second fraction. And then from there, you just do a multiplication question like we just did on the previous page. So it's essentially a multiplication question. Okay, so all you have to do is change the second fraction so it's flipped and turn it into multiplication. Then you proceed the exact same way that we did on the previous page. Okay? So either way that they present it to you, if they present it to you like this or present it to you like this, whichever way, you turn it into multiplication. Okay? I'm not gonna finish that example. We'll just go on to another one so you can see how it looks like from scratch. Alright, so if I present this question to you, you're going to use your K, C, F. Keep, change, flip. So I'm going to keep the first fraction, what it looks like. What does the C stand for? Change what? Change the multiplication, or sorry, change division to multiplication. And then F, flip the second fraction, so it becomes x squared minus 1 over 3x. Then from here, you proceed just like we did on the previous page. Factor and cancel. Okay? Can I factor x squared? No, cannot. Can I factor the trinomial that's underneath x squared? Yes, you can. We're going to use that x trick. Alright, write a small one over here. So multiplies to get 1, adds to get 2. 1 and 1, right? Can I use the shortcut?
Yes.
Okay, so it's x plus 1, x plus 1. Right? Can I factor x squared minus 1, the top of the next fraction? How would I do that?
X plus 1.
x plus 1, x minus 1, because 1 is a perfect square. Okay. So, what do you guys see? What can I chop? Okay. Do you see anything in common with the monomials? Yeah. So I had 1x here, so I can cancel with one of the x's here. So essentially, instead of x squared, it becomes x. All right. So is there anything else I can cancel? No. All right. So with what I have left, I'm going to piece them together. What do I have left in the numerator? An x and x minus 1. Remember, you don't have to distribute, just stick them together. Then what do I have left in the denominator? I have the x plus 1 and a 3. So I like to write the monomials in front, so it's a little bit neater. So 3 and x plus 1. So that would be my final answer. Okay. Finding the restrictions for division is a little bit different, right? We have to use x's that were in a denominator at any point. So I think, did I write that up here? Yeah, state restrictions from the original division and original multiplication form. So when you guys are finding restrictions, if you guys have a highlighter or something, you might want to use this. Finding restrictions for division, you have to look in all 3 of these positions. Right? So basically, after you factor, you have to look here, here, and here. Everywhere except for this. My kids like to call it the shoe. Right? So if you kind of circle it, it looks like a shoe. Right? When you guys are finding restrictions for division, you have to look here, here, and here. So it's basically everywhere except for the numerator of the first fraction. Away. Because at one point, wasn't this in the denominator in the original question? And then we flipped it. So anything that was ever in a denominator at any point within the question, you have to set those factors equal to 0. So again, you could draw a little shoe of left, I don't know, whatever side shoe you want to call it, but it has to be everything except for the first numerator of the fraction. Inside of the right shoe? I'm not sure. Whatever. Alright, so I'm going to set 1, 2, 3, 4, 5 different things equal to 0. Every x that you guys see, set equal to 0. So what would I get from this one? Negative 1. What would I get from this one? You don't have to write the same number twice. So if you get the same number twice, just write it once. So I have negative 1, another negative 1, then a positive 1, and then for my monomial, 0. So again, if you have the same number appear more than once, just write it once. You'll be good with that. Alright, so it can be a little bit longer, especially with finding all those different restrictions, but it's essentially a multiplication question. Okay? How do I approach this one? KCF. Keep, change, flip. So we're going to keep the first one. First fraction. Change what? Change the multiplication. And then flip what? Right, the reciprocal. Alright, then from here we're just going to go ahead and start factoring and chopping stuff out. Okay? So how would I factor the numerator of the first fraction? GCF of 3. So I'd have 3 and then y minus 4. How would I factor the denominator of the first fraction? A GCF of 2. Okay. What about the numerator of the second fraction? GCF of 4. So I'd have 4 and then 2 plus y. Okay. What about the denominator? Say again?
What is your y?
So see how the y is at the end instead of the front? So I pulled out, I kept the order for now. We'll see if there's a reason to change it in a second, but keep it the order the same until we get a little bit further. The GCF at the bottom is 6. Alright, now that I have this, let's see if we can chop it. Y minus 4. Those can go away. Now, coming back to what Justin was saying, I have a y plus 2 here and then a 2 plus y here. Are those the same? Yes, because addition is commutative. If it was y minus 2 and 2 minus y, those actually would not be the same. Because subtraction is not commutative. So you'd have to do something different. but you don't know that.
12 or 12, 4.
Is there anything else that I could cancel?
Multiply it together and you get.
Well, if you multiply them now, you get 12 over 12. But if you canceled them before, you would have seen that you would cancel the 3 and the 6 and the 4 and the 2. You would have ended up with 2 over 2. Still give you a 1, right? If you guys don't catch monomials, like the coefficients in the front, you'll catch them afterwards. So if you miss something simplifying here, double check to see if there's more you can do here, because that's oftentimes where you catch those coefficients that you cancel. Alright, what are my restrictions? Remember, look for the shoe. Right, the shoe right here. I have to set this equal to 0. -2. Remember, these were the same, so this would also give you a -2. And then 4. Alright, always look within the shoe for division. Alright, I'm going to have you guys do the last 2 on your own. Alright, I'll come back around and put the answers up so you guys can check. So go ahead and try those last 2 on your own. If you divide by 7,
And you like, okay, I picked the mom one. Oh yeah, definitely.
should be getting. Make sure you're looking at it. Before you combine them, look at the numbers. For the first one, did everybody at least get that far?
Yeah.
KCF? And you should notice that you could cancel x's and y's. So then the x and the y and the numerators cancel out, leaving you with only y squared and x squared in the denominator. And you can also cancel the 7 and 21 and the 8 and the 4. So that's why the 8 and the 4 leave you with just a 2 in the numerator, and then the 7 and the 21 cancel, leaving you with only a 3 in the denominator. So always be on the lookout for numbers that you can cancel as well as variables. Right? If you missed that, if you multiplied 7 and 8 together and 4 and 21 together, you would have gotten a fraction that you could have simplified even further even after multiplying. So always make sure you guys are looking for those numbers and making sure their fractions or the coefficients are fully simplified as well. Okay? Oh, restrictions on. Okay, restrictions. You have two different variables, x and y. They're both monomials. So what would the restrictions be? 0 and 0. Because they're monomials. Alright, hopefully you guys got this far, the KCF. So you keep, change, flip. For the top, what do you get when you factor that? Y.
Oh, sorry.
Okay, we have y cubed, which is a monomial, can't be factored. This is also a monomial, can't be factored. This becomes y plus 5.
Yeah.
Alright, so what cancels? What else? How many y's from each? 2. So you cancel out y squared with y cubed, leaving you with just one y left over of the 3. So then you multiply whatever's left over, you get that in the top and then that in the bottom. Okay? Then look for the shoe, right? So you look for the shoe here. So with our monomials, y can't be 0 or negative 5 or 2. Sorry, I was doing the shoe, not fine. You want to do the shoe with the factored form before you cancel anything, and then you use those to find your restrictions. Right? So they're only long when there's a lot of factoring to do, but the process is generally the same for each of these. Does anybody have any questions? Michaela?
Whether, we're using KCF or not, the restriction.
And for division specifically, it comes from the shoe as well, because at one point that numerator was in the denominator. So for division, you have to remember the shoe. Alright, if there are no other questions, you guys are free to start looking at the homework, making sure that you're comfortable with that.